All right. Good morning, everyone, and welcome to this talk. We're going to be talking about the systemd journal. So mastering the journal and becoming familiar with it, like John said. Sorry if my voice is a little harsh. I'm recovering from a sinus infection. So a little bit about me. I'm a senior technical engineer with Counteract. So Counteract challenges, we do pen testing, we do assessments, red teaming, purple teaming, and we build ranges. I am a GSE, so I'm GSE number 330. Unlike some of the earlier GSEs, I did go through the newer track. I am a SANS instructor and author of Sec 406 along with Mark Baggett, and there's the URL to the class. Now, why are logs important? John had kind of alluded to it in the beginning is, you're trying to troubleshoot an issue. You're trying to track down, maybe it's you're setting up a new tool and something happened with that tool and you don't have any output inside your shell, but maybe that tool logged to the logging facility or the logging capability that's inherent on the system. And so you go down into the var log directory and there are a ton of logs there. I mean, there are logs for, syslog or messages. You've got auth log, you've got secure, you get, tons of files in different directories, depending on what's installed on the system. And so, security professionals are going to be using this to try and troubleshoot issues or to maybe do some incident response or triage on the system. Forensic analysts or, defer analysts might be going into the logs to identify some sort of execution. Maybe somebody executed a specific tool and they're trying to find out more information about it. And it's really helpful if we have those logs centralized. And so, centralizing our log data is really important. Well, a common misunderstood capability of Linux is the systemd journal. So I asked Dolly, AI, since kind of keeping on that AI theme, I asked Dolly for an image of the Linux journal, and it provided me a magazine. So I've got the Linux journal here, and some of the text here is not very useful, and that's how some of our logs can come across. Is they're not super useful, but the journal is actually one of those really nice capabilities on our Linux systems. So what is the systemd journal? Well, systemd, as the modern Linux initialization daemon that manages all the services on your system, has its own journal facility or its own logging capability, and it's called the journal. And so it has its own daemon, so journal D, and journal D is the daemon that runs and ingests all the logs for systemd. Now, it does collect logs from various sources, and it's actually a little bit easier to query some information out of logs from journal D versus having to look at multiple logs inside of like the var log directory, even though journal is still kept in that same location. Now, journalctl is going to be the tool that we can use in order to view the log information inside of a binary log format. We can't use our traditional text parsing tools on the journal file because it's a structured format. It's binary. It actually saves space on the system by logging in this fashion. So your normal text-based logs, you might use 10 megs, whereas the journal might use half that or a quarter of that size, logging the same type of information. Now, being a daemon, it does have its own configuration file. The journald.conf, there's a lot of different settings and options within the journald.conf file that can establish settings for things like retention or how large do I want my log files to be? Should I enable maybe some specific features? Some of these settings are there by default, and we're going to look at what some of those are. Now, the journal does support some forwarding of logs. Even though it's in a binary format, we can forward it in a couple different ways. So we're going to look at both of those ways. When you look at just a normal, kind of what you would consider like a vanilla system or a brand new Linux system, and you'll look at that journald.conf file, inside of your configuration files, any line item that starts with a pound sign is a comment. That means that line is not going to be processed typically. And inside your journald.conf file, that's the case. All of these options are commented out, so they're not going to be used, or they might have a default setting. And sometimes we want to change those settings. I was actually working on a class. I was teaching a class, and all of a sudden, one of the systems just stopped responding. And it was a Linux system. Come to find out, as the containers were running in the background, they were logging to the journal, the host journal, and the log or journal actually filled up the disk on the Linux system. Linux will still function, but no new log data, no new writes to the disk will happen. Everything just occurs in memory. And so you lose a lot of information about what's happening. And the journal ended up filling it up. Well, I can tell the journal, hey, I don't want you to, fill up the entire disk. I want you to make sure you leave enough space on the disk. So I can set a setting like max uh, system max use, only use this much space, or keep this much system memory free. So I want a system hard disk space. So I want you to keep this much hard disk space open so I can still, or the system itself can still function. And so I don't end up overriding, not necessarily even overriding, but filling up my hard drive. So the system becomes unresponsive and unavailable for use. If you've ever tried to parse a really large log file, they become cumbersome really quick. Your commands end up running for a really long time. Well, you can tell Journal, I want to carve up my files. I only want you to create files that are a specific size. I want you to create log files that are 10 megs in size, or maybe 100 megs in size, whatever it is to meet your intent in order to parse those log files. Now, I can also tell Journal, I want to retain logs for this much time. And so your max retention, SEC in this case, this is the entries within the journal itself. So if I want to keep entries for 1 month or 6 months, I can specify that. And so again, all of these settings are commented out, but we need to configure some of those settings. And we'll look at just a few and a few sane examples. Now, some of our options here, the first one is called storage. Now, storage by default has the auto setting. And so if the system journal itself, like the file on disk, doesn't exist, the journal will still write in memory. So the file won't be in var log journal. So there's no file on disk. It maintains an in-memory copy of the journal underneath the var run or the run directory. So if we leave it at auto and somehow the file gets removed, we no longer are capturing things on disk. And so if we want to maintain that disk, we want to say persistent. We want to maintain a persistent copy. And so this tells the system D in the journal daemon, if the file disappears from disk, create a new one. So this is very similar to the setting in log rotate, where I want to create a new file. So there's a directive within log rotate that does something very similar. For compression, your log files, your normal text log files, get compressed by default via that same log rotation utility. So log rotate will go through, and based on the directives that are specified on the system, it'll go through and create compressed log files. And those are the type of log files you'll see under var log, like .gz or a gzipped compressed file. And there's other types of compression. That's just one example. Well, in this case, the journal will say, I will compress any file that's greater than 512 kilobytes by default, or you can specify the size. Like if you want a larger size or a smaller size, you can do that. So journal offers you some flexibility there, and it helps maintain the availability of the system, right? And so you're not using as much disk space. So storage is cheap, but still, when you're logging a lot, and you want to log a lot because of all those situations we talked about earlier, well, then you want to try and compress as much of that data as possible. Now, the journal also has an embedded capability of doing almost like file integrity monitoring of itself. And so this is a capability called the seal. Now, you do have to create a set of keys. And so there's a key that the journal maintains itself, and then there's another key that goes to another system and needs to be secured. But this allows a security professional to validate whether or not the journal's been tampered with. Has the journal been modified in any way? And so it's a baked in file integrity monitoring capability. So you don't need an additional tool in order to do that. You have the max use, like we talked about in this case. I'm saying I don't want the journal to use more than 2 GB of space on my hard drive. My max file size in this case is going to be 100 megs. So each file that gets created is going to be 100 megabytes in size. Now, there are two options when you want to forward your journal data. You have an option called forward to syslog. And so I have, both of them set here. Now, both, and this is not what my configuration looks like. I just wanted to show you what kind of the options themselves were. And so when you set it to no, you can actually set up a different capability, which we'll go over here shortly, that allows you to forward those logs off to, a central store. You can use that option, or there's another option, which we'll talk about. Now, there are two different types of journals on your system. You have the system journal, but then each user has their own journal. Well, by default, the permissions on those files are set so you can't actually do anything with them. You can't view the information in them. And so what this option split mode does is it allows the files to be split by user ID. So each user will get their own, and they'll have permissions to read their own journal file. Let's go take a look at some of those permissions. So we're going to drop over to the shell. So this is our sec406 VM. And I'm going to go over into the varlog directory. So I'm going to say cd varlog, and I'm going to do an ls-ld of journal. And the reason I want to add the D, so I'm doing a long listing, and the D gives me the permissions of that directory and lists it out as if it was a file. And my permissions on this object, so on the journal directory itself, it's owned by the user root, and the group owner is systemd-journal. The permissions on it for root are read, write, and execute. The group, systemd journal, has read, and then this small s. We'll talk about that here in a sec. Now, anybody that doesn't fall into those two categories falls into others, the others access class, and they have the read and execute permission. But there's also this plus sign. So there's two other things happening here with this file. We have a special permission, and in this case, it's called the set group ID permission. Now, when this is set on a directory, any file that gets created within this directory maintains the group ownership of the directory's group. So any file underneath journal will also be owned by the systemd journal group. But also any directory also inherits that same permission and ownership, and it nests down recursively throughout that entire directory structure. Well, that plus sign also tells us that there's an extended access control list. So in our extended access control list defines other sets of permissions that might be allowed on this file object. And we can view what that is with get facl. So I can say get facl on journal. And tells me here's what the file is. It's journal. It's owned by the user root. The group owner is systemd journal. It tells me that there's a special permission set. So my flags would show up there. And it has some permissions that you would normally see even in your ls-l output for the user, the group here, and for others. But there's some other things that are listed here. And this is what the extended access control list does. There's a defined group. So the defined group, the group name is admin, ADM, and it has permissions of read and execute. So even though the ADM group isn't a member or has any ownership on this object or anything really underneath it because of that set group ID permission, this directory is also going to have the read and execute permissions. The group admin will have the read and execute permissions. We also have some masks, so anything that gets, or some default permissions. So any item that gets created within this directory will have these permissions set on it automatically. So essentially, the same permissions that are set on this object are going to be set across any object that gets created within the directory structure. So if I go into journal, I'll clear my screen with Control L and then do an ls-l again. So notice how that same permissions, or those same permissions are nested down for the group ownership. Now the remote one we'll talk about here in just a second. And when the set group ID permission was applied, this first directory was created, and so it will inherit those permissions. This one was created by a service, and so there's some unique circumstances surrounding that. It's still owned by the root user, and the group owner is systemd journal. If I go list out that directory, there's all this stuff, and this is the actual journal for the system. There's the system journal here, and it's taking up this many bytes on my disk, and I've got my own user journal. But notice how it's still owned by the user root, and the group owner is systemd journal. And so that set or the split mode of UID would allow me to view my own log file, my own journal by splitting this out. And so every user would have their own journal. So not only do you have a journal or log for the system as a whole, but each user also has their own individual journal. If I tried to do something like, and this is going to be ugly, so I'm going to say head, let's say minus N5. I want to look at the first 5 lines of the system journal. And this isn't going to work because I don't have read permissions on it. So I'm going to have to use my sudo permissions in order to do this. Journal, oh, it's underneath 8.1. That's what your binary log file looks like. So it's not very pretty. I have to use my journalctl command in order to view this information. If I wanted to do that, so let me clear my screen. I can say journalctl. Let's look at, now -u will allow me to look at information specific to a service. So -u, and let's say I want to look at SSH, the SSH service. There are no entries, so I don't have SSH or the SSH daemon enabled on this system. How about Docker? Do I have Docker here? No. And so the specific services, you know, you can look at specific services using the -u option. Well, I have another service, systemd journal remote. That one is enabled. So I installed this service earlier as a demonstration, so we can go through how to forward your journal as a whole. But it gives me information specific to that service. Well, if this service had log align items in my normal text log files, I'd have to go search across all of those log files for all of the information related to that specific service. In this case, it tells me, here's, if my grep command looked for this specifically, I wouldn't see that in my traditional, grep command going over my text log files because that term isn't in here. It's not in this specific log line item, but journal understands that that line item or that log relates to that service that you're looking for information on. So if we had the SSH daemon enabled and we're looking for things like when's the last time somebody logged in, is the SSH daemon running, what port's it running on? The journal is going to have all of that in one output when you look for the SSH daemon service. Whereas, you'd have to look in the auth log or secure and your syslog, and maybe a couple of other log files, depending on the system and its configuration. Journal has a grep capability as well, but when you're using the kind of the embedded journal, so if I say journalctl -- grep, and let's say I want to look for systemd journal remote, it'll do a search for that. And notice in this case, it's not only the line items relating to the service, but also when did I install it? What specific items were logged for it? So for example, here's my sudo utility. I modified some log file or the configuration files for this utility. So it captured that. It captured all that information inside of this journal. Well, the grep command is great, but it only works for like essentially like single terms. Don't think of this as like a full-fledged grep where you can do recursion and lots of other. I mean, you can't do recursion because you're looking at a single file. But if you're trying to use options and get real complex with your grep command, you want to pipe the output of journalctl to grep in order to view that information. All right, so that's the journal. And we looked at some permissions. Now, forwarding the journal, you have really two options. One is to take the data that the journal is recording. Since it's binary, the syslog is going to capture some of the same information, and you might have some duplicates because the journal is capturing information, and so is the system log. But if you choose to forward the syslog or the journal information to your syslog, you might have some duplicates. But it allows you to, one configuration that forwards off all that information off to like a SIM or a centralized log store capability. The other option is to tell journal itself, I want you to forward the journal as it is, as a binary file, over to maybe a central journal collector. And then from there, we can do some parsing, almost like the same that you do for like your text log files. And there's a capability to centralize your journal, and things like the Elk stack can understand the journal structure and ingest that log data. So Taz Wake, the author of Forensics 577, posted a LinkedIn article on how you do the option one, forwarding your journal to the local syslog. And he provides a couple of examples. One was through our syslog, which is called the Rocket syslog daemon. Traditional syslog isn't really used as much anymore. You really have two normal syslog services or daemons on your modern Linux systems. It's either R syslog, which is your Rocket syslog service, or syslog ng. But let's take a look at option two. So we want to set up some journal forwarding. It's a lot simpler than you think. So it's based on a server client model, and it's all done over HTTP or HTTPS. And so you install a software package. It's called systemd journal remote, and you install it on both sides, on the server and the client. Now, once that's done, on the server side, you modify the service. You can tell the service, hey, I only want you to listen in HTTP. I only want you to listen in HTTPS. I want you to put the files in this directory. Once that's done, you do a daemon reload and you start the socket. Now, the socket itself has a default port assigned to it. You could change that port. Like if you don't want to use the default port, you can change it to something else. Now, on the client side, you modify one configuration file. You tell it where that server is. So you give either an IP address or a fully qualified domain name, and then the port, and then you start the service. And this is a different service, but it's part of that same software package that gets installed. So this one's the systemd journal upload. And so very simple. And once you have both sides set up, it starts ingesting immediately. So we go back over. I've got two systems. I've got this is my server, my sec406 virtual machine. If I go look at my my configuration files, so we'll say so here's my unit file. So this is the service definition file for that remote, so the software package that we installed. There's only one thing that I changed in this configuration, and I changed it from HTTPS to HTTP. I deleted an S, and then I started it. That was it. The output of where to put this information is defined on the same command line. So my exec start directive and my service unit files tells the service what to execute when it starts. There's a bunch of other directives that can be specified in here. There are things like, I only want this service to run as a specific user. And if the user is not defined, it's going to run as root. In this case, we do have a user defined, which is part of the reason why those the directory and the log files themselves have the ownership that they do. It's because of the systemd journal service or remote user. Now, if I wanted to use HTTPS, I'd have to modify this service, add the S back in for listen HTTPS, and then configure some certificates. So I need, the server certificate, and this client would have to trust that certificate. And then all of your log traffic is communicated over an encrypted connection, which provides another layer of security. If we look at the socket, this is the port that the service is going to listen on. So the port, if I wanted to modify this from the default port, or if you're doing some sort of testing in an environment and you see a system listening on port 19532, maybe you want to try and listen in on some traffic and see if you can view any of the log data that's going across. It's going to be in a binary format, so it's not going to be great. But if you wanted to modify that port, you can do that here. You'd modify the port on the server side in the socket unit definition file, and then restart the service. Now the server's fully set up after that. That was it. On the client side, I did the same thing. I installed the service and I modified this file. So journalupload.conf, and down here at the bottom, I've defined, so I'm just using IPs because I'm talking two VMs. So I would define my IP address, and then there's the default port. So that socket that the server's listening on. If I wanted to define or I wanted to, make this HTTPS, I'd have to change this to HTTPS and then define where the keys are once they're created on both and that they exist where they need to on the server and the client side, and then restart the service here on the client side as well. So that was the only line I modified there. And then I started the service. So I said systemctl enable now that service. So I can take a look at it. Systemctl status, um, system D journal upload. And there it is. It's now uploading the logs to that central log store. So if my sec406 VM was my central journal collection point, I would now have that log data. And so when I look back over at this directory structure, and if I do an ls-lr, here's my remote directory, and that was specified in the output option or parameter in that service definition file. It said var log journal remote. And so my remote directory got created, and here's that remote journal coming in from that distant system. So I have all of my journals being collected in one central location. Now I can do, like I said earlier, if on your SIM, you wanted to do some specific parsing of the journal, or you wanted to make one central location for all your journals, and then maybe forward them on to a syslog server, that's another option. But in this case, we're collecting our journals first before we do anything else with it. Now in Sec 406, we talk about a lot of logging and how to configure logs. We talk about the journal, we talk about your normal, we talk about our syslog because it's a Debian-based class, but we do cover items that are related to your Fedora and Red Hat-based. And we do cover SE Linux. We cover the different ways of managing the net filter packet filtering framework on Linux, whether it's through IP tables or NF tables, UFW or firewall D. We cover permissions and special permissions and those extended permissions. It's jam-packed full of lots of information. We cover things like how to be more proficient or efficient on the command line. There's a lot of really good content here. If you're interested, take a look. There's a demo, I believe, for the class. And again, thank you for joining.